Good morning. Today we're going to look at the last form of transformations, which is the dilation. What I've got for you to start with is a little fun intro video on dilations. Hopefully this will help give you a little preview of what we're going to be talking about in our notes. So as you watch this video, I would take some notes if you want to, or just pay attention as it goes through.
In math, dilation refers to the process of making a polygon larger or smaller without changing its shape. It's picture day. Kate chooses the package with one photo for her parents, a larger one for her grandparents, and smaller photos for her friends. How can photographers print one photo in different sizes? Dilations. Dilation is where a two-dimensional shape grows or shrinks proportionally from a point called the center of dilation. Here we tripled the original rectangle, and here we divided it in half. In dilations, the dimensions and distances from the center of dilation stay in proportion. The center of dilation can be anywhere in, on, or outside of the shape. Scale factor determines how a shape grows or shrinks. If the scale factor is 3, the dimensions from the center of dilation are multiplied by 3. Different sizes, same proportions, same shape. A coordinate grid can help us see how this works. If the center of dilation is 0, 0, and the scale factor is 3, the horizontal distance from the center of dilation is 3, and the vertical distance is 4. Multiplied by a scale factor of 3, the horizontal difference becomes 9, and the vertical distance becomes 12. Stretching the shape 9 units to the right of the center of dilation and 12 units up. Nice portrait, Kate. Grandma and Grandpa are so proud. If the scale factor is 1/2, the original dimensions are multiplied by 1/2. The dimensions of the reduced photo are 1.5 and 2. Different sizes, same proportions, with dilations.
Alright, so I think that little video kind of gives you a brief overview of what dilations are and how they're going to work. So we're going to walk through this little piece by piece to make sure you understand all the different parts. So first we need to know what a transformation actually is by definition. A dilation is by definition. It's a transformation that produces an image that is the same shape as the original, but it's a complete different size. The picture will either grow or shrink, so as you can see, our small dog compared to our large dog, this is a dilation of the original. You will still have C as your beginning and C prime as your new image point. So let's look at some characteristics of what dilations are. So it's a little easier to pick them out to be different from rotations, reflections, and translations. The first characteristic is that the pre-image and image are similar, where the other 3 types of transformations, all the shapes are congruent. These will not be congruent. You need to look to see that the sides are proportional and that the angles are congruent. If the angles are not congruent, the shapes will appear to be different shapes. Second characteristic is that you're going to have a scale factor, something that you're going to multiply by to increase the size or decrease the size of the original shape. And finally, the third characteristic that you need to understand is that when you dilate around the origin, that point 0, 0, all you do is multiply. Even if you have a fraction, you still multiply by the fraction. All right, sorry about that. So again, for the last one, you will multiply whether it's a fraction or not. Whole numbers are a whole lot easier to multiply by, but when you start shrinking your pictures from the original to a smaller figure, you're going to have a lot more fractions involved. So by definition, a scale factor is just the ratio of the side lengths from corresponding side lengths of the image in the original figure. So you have to figure out how does one change from one to the next. Notice it's from the image to the original. So you start with the new part back to the original. Again, it's going to tell us how much smaller or larger our picture will change. So here is a way to do it mathematically. You can find your scale factor, which appears to be a fraction, with the image length, that's the final length, over the pre-image, what you started with. So we're going to take a look at how we can figure that out and see some characteristics of these scale factors. So let's start with one that is actually growing. So when you put it into the fraction, if your answer comes out to be greater than 1, then it is going to grow larger. This is called an enlargement. So if you look at your picture, point A is going to stay exactly where it's at if it's on 0, 0. But if I look at B to B prime, you can see that it is growing larger. Same thing about D to D prime and C to C prime. But if I look at a scale factor that is less than 1, it's going to shrink. You could call that a reduction. It's going to reduce in size. All my original points, H, E, F, and G, are going to reduce. They're going to shrink away from the actual point of the original image, that pre-image. So let's actually try to find some of these images. So you can see here that 2x and 2y will be a dilation. It's telling me to times the x value by 2 and the y value by 2. So we have our original ordered pairs. I've gotten these off of the picture over to the right. We have a -3 and a 4. If I take and times 2 by -3 and the 4 by 2, the 2 coming from our rule, then I can get my final ordered pair to be -6, 8. I've just doubled the values. For B, if I have 2 and -2, again I'm going to times both values by 2. So 2 times 2 and 2 times -2 will give me B prime as 4, -4. I want you to try C, so pause the video, do your multiplication to see if you have the right answer revealed. Alright, so let's see if you got it. So 4 times 2 and 1 times 2 will give me C prime to be 8, 2. If you did not get that at this point, I would raise your hand and call me over so I can help you walk through this process. Now is matching. On your paper, I want you to draw lines connecting the rules to the final answers. This one, the rule is a little bit different because you can see a little subscript number beside the D, D meaning dilation. So this little 3 in this example at the bottom of the paper is the scale factor, meaning I'm going to times all numbers by this value. So if I was looking at D sub 1/4, this is scale factor of 1/4, meaning I'm going to times both values by 1/4. I would pause the video, try your multiplication, draw your lines from column A to column B, restart to see the answer. So here are the answers for this activity. For the dilation of 3, if I times -5 and 4 both by 3, I get -15 and 12. 1/4 of -40 and 1/4 of 12 will give me -10 and 3. And you can look at the yellow and green line. All you're doing is multiplying by the value that is the subscript with the dilation D. So now you have to go back and actually determine what the scale factor is. So you have to look at your ordered pairs and figure out what can I multiply by to get from the original to the new, or looking from the new back to the original. Again, for your scale factor, you kind of want to work backwards. Start with the new image over the original. So if I look down here at A and A prime, I start at -6, 0, and it changes to -3, 0. Look at B, 5, 5 to 2.5 and 2.5. And for C, going from 2 to -7 and 1, -3.5. Most of you should be able to look at these and easily see what's happening to our values. If I'm going from prime back, you can see that my number is growing. If I'm going from the original to the new, it's shrinking. To figure out if it's an enlargement or reduction, you need to take the -6 and the -3 and plug it into that formula. So let's go back and look at that formula real fast. So I take my image length over my pre-image. My image over my pre-image. So -3 over -6 and reduce it should give you that it's a reduction by 1/2. Again, if I take 2.5 over 5, if I take 1 over 2, always put your image over your pre-image to figure out your scale factor. So at this point, we're going to look at some examples, working them out to figure out the proportion, the scale factors, and what my new ordered pairs are going to be. I'm going to start a new video so we don't run out of time on this one. So I would go ahead and stop this one, enter in the new web address to watch the new YouTube video. Hopefully this helped. If you're still confused, I would rewatch this or raise your hand for some assistance.